I did put a question in the poll, so I am prepared to ask a poll question. But the only thing that I'm scared of, guys, is that we might not have enough time if I do the whole poll question, because this question is a unique one. So I think I might just skip it. But if you guys really want to do that poll feature, I can do it. So yeah, let's get started. So here is, don't worry, we're gonna give you guys time for your quiz. And the quiz, I made it easy. There's only 2 questions on the quiz. Yeah, only 2 instead of 4. So I made it easy for you guys. So all right, so here are the notes that we already know. Let's see. We know all these already. And the 3 that we're gonna be focusing on, guys, we're gonna be focusing on these 2. Make sure, guys, that sometime in the next 5 minutes you come in within view, please. We would really appreciate it. So these 2 with the X's are the ones that we're gonna be focused on. So before I continue, let me ask, do you guys agree that A is half of 2A? Nod for a yes or not. I guess this is nod, right? What is this called? I mean, I know that's called yes, but
this is nodding your head. And
that's nodding your head.
And then what is this?
Shaking your head.
Shaking your head. Okay. Nod for yes. Do you agree that A is half of 2A? Okay, awesome. We agree with that. All right. So because we agree with that statement, I can rewrite this first bullet, guys. So I'm gonna, whatever's in red is gonna be for that first bullet. I'm gonna take up half this page here. So I'm gonna rewrite this as this. And I'm gonna write this on the left-hand side. So I'm gonna rewrite 2 cosine squared of, let's see, that's half of A minus 1 equals cosine of A. Before I continue, do you guys agree with that statement? Okay, perfect. Rubio says she agrees. So now from there, what I want to do, guys, is I want to solve for cosine half A. So what I'm going to do is I'm going to add 1 to that side. So I'm going to rewrite it like this, 2 cosine squared half A. And I'm going to put the 1 in the front, 1 plus cosine A. And you don't have to put parentheses, but I've been putting parentheses, so I'm going to continue to put parentheses. Is everyone still okay with that statement? All right, next what I'm going to do, I have a 2 in front of this cosine half A. I'm going to divide by 2, divide by 2, divide by 2. And I'm going to go slow. Cosine squared half A equals 1/2 plus cosine A over 2. Do you guys still agree with what we have so far? All right. Next, I'm going to factor out a half. Delta math, and don't get me wrong, I love delta math, trust me, I love delta math. But delta math does not have this formula written this way. They have it as 1 plus cosine A all divided by 2, and that's okay. It's just a different way of looking at it. Delta math is okay with dividing. I prefer to just multiply everything. So it's just a different way of looking at it. The only thing we got to do left is get rid of that square. So we get rid of that square by doing the square root. And here is your half angle formula, guys. Plus minus on the front, 1/2, 1 plus cosine A. And yes, I'll write the delta mass formula. This is the one that I prefer. And let me write the one that delta math has. Delta math has cosine half A equals plus minus, and delta math has it as 1 plus cosine A all divided by 2. And all of that is inside the square root. If you prefer the delta math one, that is okay. You will get the same answer. I just prefer the half factored out. I think I prefer that way because most of my professors would use it that way too. Mm-hmm. Yes. Mm-hmm. All right, guys. I'm going to go ahead and do now the other one. Oh, or any questions before I continue? Do we have any questions on that? Okay, it's just a formula, guys. We derived it. I just wanted you guys to see where it comes from. So now I'm gonna go ahead and color code it. Where you see the blue bullet, that's where everything in blue is gonna be from. I'm gonna write the 1 minus 2 sine squared of half a on the left. So I'm gonna write 1 minus 2 sine squared of half a equals cosine of a. So write that statement first. And then I'm going to move the 1 just like I did in the other one, guys. So move the 1 to the right-hand side. So when you do that, you're going to have negative 2 sine squared of half a equals, let's see, negative 1 plus cosine a. And you can already see where I'm going with this. And if you can't see where I'm going with this, it's okay. I'm just going to divide everything by negative 2 here, like so. So I'm going to write sine squared of half a is equal to negative divided by negative is a positive minus cosine a over 2. And I guess you could leave it like that and combine like terms if you wanted to look like the way delta math looks like. I'm going to go ahead and factor out a half on the right-hand side. So I'm factoring out a half right here, Rubio. So I put 1/2, and now you see I'm going to write 1 because half goes into half one time, right? Minus, and then cosine a like so. I guess if it bothers you guys, the formatting there. And there's a square, and yes, I missed it by accident. Now next, I want to get rid of that square, so I'm going to square root it, and then finally it goes away. So there it is with the square going away. I put plus minus in the front, and let me minimize this. Square root 1/2 like so, and then I write 1 minus cosine a. And if you use this expression 3 times, you will have it memorized. Don't freak out when you do the delta math. The delta math, like the cosine, the delta math has it like this. Sine of half a equals plus minus, and they write it as 1 minus cosine a all divided by 2. It's the same. Which one do I prefer? I prefer the one that is boxed. It looks beautiful. I think it does. I hope you guys think it's beautiful too. It almost looks like art, which is ironic because I failed art. Yeah, let's not talk about that. So yeah, so we have one more to do, guys. We have the tan half a, and I'm not gonna go like full throttle in it, but I do want to show it to you guys. So we still got some space down here, and I don't want to bore you. Oh, what's up, Miss Harris? I didn't see you there. What's up?
I'm just a little confused. Why are we solving for 1/2 a?
Oh, I just wanted to. I don't want to cheat you of your education, so I'm trying to derive the formulas like where they come from. So I did a bad job of introducing. I should have said, let's derive. See, I wrote it, but I didn't say it. Let's derive the half angle properties. So it's my bad for miscommunication. I want to derive the half angle formulas for sine, cosine, and tangent. Cool. Just like the composite argument properties like cosine a plus b, cosine a minus b, I want to derive, like I want to know what is cosine half a equal to, get me an equation. What is sine half a equal to, get me an equation. What is tan half a equal to, give me an equation. Yes, last time we were working on double angles, Ms. Cruz. So now we're working on half angles. So they're related. Okay. Did I answer your question, Ms. Harris? Okay. All right, guys. Last one, and we'll go kind of briefly through it. I want tan of half a. Well, tan of half a, I know is sine of half a over cosine of half a. And don't worry, if you don't know where these formulas are coming from, that is fine, as long as you know how to use them. Sine of half a is equal to this expression in blue. So I'm gonna write plus minus square root 1/2. 1 minus cosine a, all divided by plus minus square root 1/2, 1 plus cosine a. We all took algebra 2, so hopefully we are all pretty good at laws of exponents. So I can rewrite this as one giant square root with 1/2 1 minus cosine A in the top over 1/2 1 plus cosine A in the bottom. I can cancel out those halves. And now what I want is, really I can multiply this 1 minus cosine A over 1 plus cosine A. I can multiply it by whatever I want to multiply it with, as long as it's a conjugate of a numerator or a conjugate of the denominator, it does not matter. So I'm going to go ahead and multiply it, or you guys, I'll tell you what, you guys will decide. Do you want me to multiply this by 1 plus cosine A over 1 plus cosine A? So you guys will, I'll write this, and you guys tell me if you guys want me to do that. Thumbs up. Okay. I see that you guys want me to multiply by this. I was going to say the other one, but I think there's more thumbs up than no. So I'm going to go ahead and multiply by that, guys. When I do that, here's what I get. I get giant square root, and I get this turns into the difference of squares. So I guess I'll write it down just to be specific because I want to give you guys the best notes. All over in the bottom, you're going to get, and I'm not going to distribute this. I'm just going to write it like this. Now, hopefully you remember difference of squares is just 1 minus cosine squared A. You feel okay, guys? I know it's pretty late, guys, and I know that we're all tired here. All right, hopefully you remember that sine squared plus cosine squared equals 1, because that's the Valentine's formula, and Valentine's is coming up, guys. So I'm telling you, write it in that form. Okay, really quick, guys. Honestly, you should write a Valentine's letter to your boy or your girl. You know, we don't judge. And if you tell them that you're cosine squared and they're sine squared and together you guys are 1 and they do not get it, I'm being totally serious. You should really have a talk with them. I'm not telling you to break up with them, but you need to have a talk with them because I mean, come on, how do you not know that? Like that is before you graduate, everyone needs to know cosine squared plus sine squared equals 1. All right. Anyways, there. I have done my job in educating everyone. I'm going to replace that with sine squared. And now that I have that square root there, well, square root of sine squared is just sine A. That I can do. Travis, why can you do that on this one? But when I try to do 3 squared plus 4 squared and the square root of that, I can't do it. I can't just, well, because this is just one term, guys. And this right here, look, it's a 1 plus cosine A, and that has a parenthesis on it. So that acts like one term. It's not a one term, it's 2 terms. That's called a binomial. But it acts like one term because it has a parenthesis. And there's a square there, so that square and square root does cancel out. And you get 1 plus cosine A. So there it is. Tan half A actually has 2 formulas, but we're just going to leave it like that. Cool? All right. So check it out, Ms. Harris. If you go to the next page, I could have just done this. I could have just put this on the front and say, we're just going to use those formulas. So on the next page, now you see where all of these formulas come from. I hope you guys can see that. Now, because I don't want to be fake. I want to show you guys where they come from. So we did them all, guys. We look. So now you know. So if a professor ever tells you, I want to know how those half angle formulas are derived, you can just tell him or her, be like, all right, professor, well, hook me up with the double angle formula. And with the double angle formula, I'll write your half angle formula. And there it is. All right, how do you use this? Let me show you how to use it, guys. So it says if cosine A equals 15 over 17, and A is in the open interval 270 to 360, so that means A is some angle, and that angle is somewhere between 270 degrees and 360 degrees. What angle is it? I don't know. Can we figure it out? Yes, we could figure it out. We'll wait for letter C for that. It wants to know what is the exact value of cosine half A. All right, that's a half angle formula. I'm going to start by writing my formula first. Cosine half A is equal to plus minus in the front, square root, put a half, 1 plus cosine A. That's the formula I'm going to use. So here we go, guys. I'm going to write plus minus, square root, 1/2, 1 plus, they tell me what cosine A is, and I can see some of you guys are still writing, so I'll slow down. Cosine A is 15 over 17. So I'm going to write 15 over 17. And let me slow down. Now that I know that I already put that what cosine A is, can't even talk right. Sorry, I was just reminded of, there's a movie called Dodgeball. Have you guys ever heard of that movie? There's a scene on the dodgeball scene. I guess we got to tell Mr. Studio to show it to you guys because it's like marvelous acting. It's a comedy. There's a scene that it goes, I don't think that you think that I thought that I was once as dumb as I thought that you thought I was, or something like it was, it's a tongue twister, guys. It's pretty extreme. I didn't, I just, okay, anyways, something like that. 1/2 parenthesis, that 1 turned into 17 over 17. I'm doing this because I don't want to use the calculator. So in case you're wondering, like, Chavez, what are you doing? I'm trying to simplify. I'm trying to get a number out of this. So from there, no, I don't think I got it correctly, miss. I think I tried to get it correctly, but I didn't. The quote there. From there, I'll go ahead and add 15 plus 17. I think that's 32. I shouldn't say I think. I know it's 32. 1/2 parenthesis, 32 over 17. And then make life simple for yourself, guys. Make it simple. 2 goes into 32 16 times. So now that we know that, finally, we have plus minus, and then we have square root of 16 over 17. And we all took algebra 2. So we know that laws of exponents comes into play. So I can rewrite this as square root of 16 over square root of 17. If it's free response, I will accept 4 over square root of 17. Unfortunately, a lot of your quizzes are multiple choice, and you have to figure this out. So the way to do that, guys, just multiply this dude by square root of 17 over square root of 17. And finally, you get, I'll write it down here, plus minus 4 square root of 17 over 17.
Wait, could you repeat why you multiplied it by 17 or the square root of 17 again?
Yes, of course. I do not want to have a square root at the bottom. I'm trying to delete that. You know what I mean? That is called, what is that called? Rationalizing the denominator. Okay, last. Well, no, I wouldn't give you the awkward face. I would probably put like, okay, if it was free response, I'd leave it. I'd be like, okay, that's fine. But professors, I think, are still old school and they want it in the top. Plus, you know, it makes life easier with computers to have it written a certain way. All right, guys. Last but not least, is it positive or is it negative? I don't know, Travis. You're telling me. It is the first time I'm seeing it. Take a guess. How would I figure out whether it's positive or negative?
You look which quadrant it's in.
Miss Cruz, you are absolutely correct. You are super smart. You look at what quadrant you're in. Yes, that's exactly correct. Now be careful. It's not cosine of A that I'm looking at. I'm looking for cosine of half A. I'm looking for this angle. So we gotta find where cosine half A is at, like what quadrant it's at. So you just take, Travis, how do you do that? You just take half of that. What's half of 360? 180. What's half of 270? Oh, I don't know, Travis. I got to think about that one. It's 135, guys. So there it is. So half angle, half of A is between 135 and 180. What quadrant is that in?
Quadrant 2.
Quadrant 2. In quadrant 2, is cosine positive or is cosine negative?
Negative.
That's right. Look at you guys doing super awesome, interacting. It's a negative one. Good job, guys. You guys actually did fabulous there.
Maybe later we can do
Not that you
breakout.
guys don't do fabulous at other times. You guys are always fabulous, but we're doing good, guys. It's because the cat is here. The cat is just chilling. You didn't see the cat? Yeah, on Zoom. He's fluffy. He's a fluffy cat. You know what? I bet you school would be so much better if we could have cats and dogs all chilling around us. I mean, I don't know. If you have allergies, I bet you're probably like, nah, that would not be ideal. But if you don't have allergies, I think school would be so much better if we could just imagine like just having a cat right here, like get out of here, cat. Like okay, I'll stop, guys. Let's just continue with this here. So now it wants me to figure out what cosine 2a is. All right, no big deal. We did this yesterday. Yesterday we did double angles. And you told me, look, they gave me cosine. So there is a formula that just uses cosine. I think it's 2 cosine squared of angle A minus 1. Was that the formula? There it is. See that? You guys already memorized it. So I'm just going to plug in. And at the university, they call it plug and chug. But I don't know if that's appropriate for high school. Have you ever heard that term before, plug and chug? No? Okay. Plug and chug. No, it doesn't mean anything, guys. It really doesn't. Plug and chug literally just means they give you numbers, you're just plugging them in. That's all it means. At least I picked that habit up at the university, plug and chug, but I don't know if it's like a common phrase to say nowadays. So here we go. We're just plugging in. 2 open parenthesis. What is cosine A? Cosine A is 15 over 17. I'm going to square it, minus 1. Hopefully I remember how to square the 15 and the 17 there. 2 parentheses, 15 squared. I know for a fact that one's 225. Now, once we get to the 17 squared, I want to say 17 squared is 289. I'm going to check myself in a little bit. Check myself before I wreck myself. Oh, you guys are too young for that. I don't think you guys know what I'm talking about when I say that. 289. Yeah, it is. They have? Like, you've actually heard of it. Like, check yourself before you wreck yourself. Wow, I'm surprised.
Yeah, I had a teacher who would always say that. She was like really mean. She'd be like, you better check yourself before you wreck yourself. And I was like, oh my God.
I think that's like a 70s thing. So I don't know what generation that is. Generation Y. Like, check yourself before you wreck yourself. Like, I don't know. Tell your parents, see if they know. So from there, I'm just gonna double the 225. We can do that, right? If I have $2.25 and I double that, I have what's that? 450. So 450 over 289 minus 1. And then I can do that. I can move that 1 into 289 over 289. So 450 over 289 minus 289 over 289. And then I'll just subtract. Oh, I just failed epically. Let me tell you why, guys. No, it's funny. The whole point of me showing all this detail and all this work is for me not to use a calculator. And I just realized just right now, I typed in this little calculator right here. I typed in 450 minus 289. I was trying to show that you could do this without a calculator, man. Okay, anyways, there it is. Those other steps. You can do it without a calculator if you really try. This is my answer, 161 over 289. All right, letter C. Let's see what letter C says. Verify your answers numerically by calculating the values of 2a and half a and finding the cosines. All right, so all they're telling me on this one, guys, is what is half a? They're telling me to check with a calculator. So all you got to do is sit back and observe, and I want you guys to see how beautiful this is. So check this out. I'm going to share my screen. Where's Desmos? Okay, hold on, guys. I need to find it first. Share. Okay, there we go. And check this out. Desmos. First, I'm going to find the angle A. Graphing calculator. And you know what? I can actually just move this part all the way to the right. So let me move this because I don't need that. I don't need that much space. All right, here we go. First, let's find the angle A. So it was cosine A equals 15 over 17. Was it? Yeah. So I'm going to put 15 over 17. And there's my angle, but that's in radians. I don't want it in radians. Excuse me. I want it in degrees, so degree. All right, so there is my angle. And no, that is not the right quadrant. So let's see. What am I going to do, guys? What do I do to get the right quadrant? By the way, I'm calling it A equals, so I can store it. A equals. All right, to get the right quadrant, I'm going to put a negative in the front, because remember the plus minus are cosine, and I'm going to add 360. There it is. Oh, let me delete the 360. So there it is. I'm in the right quadrant. Angle A is between 270 and 360, so that's quadrant 4. So there it is. Angle A is 331. If I did it correctly, I guess first let's find out. What was cosine half A? It was 4 square root of 17 divided by 17. Okay, first let's see what that number is really quick, guys. Divided by 17. All right, so that number is 0.9701425000145. It better be the exact same digit per digit. Let's see if it really is. I'm going to type cosine, and I'm going to put 0.5, or no, I'm going to use half. And I'm going to type in the letter A right there. And let's see if I get it exactly. Perfect. By the way, it should be negative. We circled the negative. I forgot to tell you that. It's perfect. Look, digit per digit. The exact same digits all the way through. Isn't that awesome, guys? I think that's super awesome. And then what did we get for cosine 2a? I already forgot the fraction. 161 over what? 289. No problem. So 0.557. So let's see if we get that. I'm going to write cosine, and I'm going to put 2a in there. 2a. And look at that, guys. Digit per digit, it's the exact same thing all the way through. That's awesome, right? Can you see?
Oh, yeah.
Okay. I think this is awesome, guys. I think it's beautiful. It proves that our formulas are correct. So I think we're onto something. Okay, so here we go. This is a question from UH. And let me know if I'm going too fast. It asks for cosine of x over 2. So if I want cosine of x over 2, first start off by writing the formula. Recognize that x over 2 just means half of x. So cosine of x over 2 equals plus minus square root 1/2 1 plus cosine of x. That's my formula. I'm going to plug in. They tell me what cosine x is. Plus minus square root 1/2 1 plus what says minus there. So I'm a minus a negative 1/7. All right. From there, you can just do it by hand, guys. And look, I'm going to go slow. Plus minus square root 1/2. That 1 is like 7 over 7. 7 minus 1 is 6. Keep the denominator. 2 goes into 6 3 times, and I'll slow down. I can see you guys writing like crazy. So let me slow down. 3 over 7. How did that happen? Because 2 went into 6 3 times. The laws of exponents, plus minus square root of 3 over square root of 7. I'm going to multiply the top and the bottom by square root of 7 over square root of 7. Because I'm rationalizing the denominator. Perfect. 7 times 3 is 21. Plus minus square root of 21 over 7. I look at my answer choices. Delete, delete, maybe, delete. And because my two answer choices of plus and minus are in there, letter F is out. And now what? Yeah, how do we do that? We got to figure out where is cosine half x at. I guess I should write it the way they wrote it. X over 2. All right. Well, what's half of 180? 90. What's half of 270? 135. Oh, you did that one fast. So because x over 2 is between 90 and 135, that is quadrant 2. And in quadrant 2, cosine is negative. Perfect. You guys are ready for university math. All right, let's keep going, guys. This is a question that I had of the poll, but I came to realize that you need experience with this, and we haven't done a single one where I give you a sin x. So is it okay with you guys if we do not do a poll for today and we'll start doing polls in future? Okay. So here we go. They tell me that it's an acute angle. What does that mean? That it's cute? That I have a cute angle? Okay, I thought it was funny, but Rubio gave me like, nah, that's not funny. They want to know what sine x over 2 is. So first, I would write out the equation, what sine of x over 2 is. Sine of x over 2 is plus minus square root, put a 1/2, 1 minus cosine of x, close. That's just the formula. I have not done anything. Then I draw acute angle. I'll stop. That wasn't funny. So here's my acute angle, angle x there. It's less than 90 degrees. And sine is opposite over hypotenuse. Sine is opposite over, yeah, it is opposite over hypotenuse. Square root of 15 over 4. I need the adjacent side. I need that horizontal displacement. So here we go. Square root of 4 squared minus the square root of 15 squared. This is just a term and the inside being squared, so that can be deleted. And then 4 squared is 16. So 16 minus 15, that's 1. And the square root of 1 is 1. So this is 1. And here on the side, I'm going to write what cosine of that angle is. Cosine of angle x is adjacent 1 over hypotenuse, 4. Cool, okay. Hopefully we're not doing too much today, guys. I hope that you guys still feel alive and well. So here we go. Plus minus square root 1/2 parenthesis 1 minus what is cosine 1/4. I'm pretty much done. Everything else is just algebra, just moving stuff around, plus minus and all that good stuff. Oh, actually, I don't even need the plus minus. This is an acute angle. It's a acute angle. So they're all positive, guys. So they're all positive. Square root 1/2. If I have $1 and I give someone a quarter, I have 3/4 left. I mean, I guess you don't have to do that for advanced math. Then 1/2 times 3/4, you just multiply those two numbers out. Square root, 2 times 4 is 8. So 3 over 8. And then I'm just doing my laws of exponents. Square root of 3 over square root of 8. And I'll slow down a little bit. That's square root of 3 over 2 square root of 2. How did I get that? 4 times 2 is 8. And the square root of 4 is 2. So now what I do, I just multiply the top and bottom by the square root of 2 over the square root of 2. So square root, anytime you're multiplying a square root times the square root, you can multiply the inside numbers, guys. That's a square root of 6 over, and then square root of 2 times square root of 2 is 2, and then 2 times 2 is 4. So there it is. I look for that answer. I thought that was pretty cool. If you guys love these questions, then you will love the level 2 subject exam for SAT. By the way, this might be the last year to take that exam. So if you want to take that exam, take it this year. And if you don't care about it, then don't worry about it then. Last 2 questions, and don't worry, we're almost done. This is coming from UH. Look, I'm doing a lot of examples, Rubio. I listen to criticism, guys. You guys wanted more problems. I'm doing more problems. 5 examples, every note, no matter what. If you want 10 examples, we'll add 10 examples. We'll do as many as you guys want me to do. All right, here we go. Sine of 7 pi over 8. So first and foremost, when you get to a question like this, you got to recognize, Chavez, what are you trying to tell me? What am I going to recognize? Recognize that this is a half angle. I can rewrite this as sine and put a half on the outside and write 7 pi over 4. See? Half times 7 pi over 4 is 7 pi over 8. And 7 pi over 4 is an angle that I know for a fact. So here in the top, I'm going to put side notes. I know my half angle formulas. Sine of half A is equal to plus minus square root 1/2 parenthesis 1 minus cosine of A. So all we are doing, bless you, all we are doing is rewriting the formula. That's all you're doing, guys. So I'm just rewriting this part. Plus minus square root, bless you, 1/2. 1 minus cosine. What is my A? A is 7 pi over 4. Have I lost anyone? Bless you. All right, next. If you have your unit circle, that would be it would be cool. Hopefully by now you kind of already know how the unit circle looks like, but if you don't, I'll do a quick sketch right here. And 1 minus, well, cosine of 7 pi over 4. 7 pi over 4 is in quadrant 4, guys. Square root of 2 over 2, negative square root of 2 over 2. Cosine is the x value, so I write square root of 2 over 2. Don't worry, guys, we're almost done. Plus minus, salud, bless you with the third power. 1/2. And I can turn that 1 into 2 over 2. So I'm going to write it like this. 2 minus square root of 2 over 2. And I'll wait for you guys to catch up. Bless you. No, you're about to sneeze again. Oh, no. I think the record for the most consecutive sneezes, I think, was like 15 or 16. Yeah, I counted. No, like in a class, in this classroom, like someone sneezed 16 times in a row. It was like amazing. 2 times 2 is 4. That's in the bottom. The numerator stays as 2 minus square root of 2. And now I'm just using my laws of exponents, guys. Square root of 2 minus square root of 2 over square root of 4. If you guys ever seen the movie Inception, I like to say square rootception. But if you've never seen the movie, then you won't get it. Because there's square roots within square roots, right? Okay, anyways. So square root of 4 is 2, so plus minus 1/2. Square root of 2 minus square root of 2. This is actually a very common UH math contest problem. Oh, by the way, if you're going to be competing in UH, I need to register you guys individually. We'll do it some other time. We still got a few more days. So there it is. There's my answer. And I look for it. So let's see. Out, maybe, out, and maybe. I just got to figure out where I'm at. This is the angle you're looking at. So say sine 7 pi over 8. Think about it. 7 pi over 8 is in what quadrant? I don't know, Chavez. You tell me. Yeah. Pi over 2, pi, 3 pi over 2, 2 pi. This is so close to a full pi. It's 7/8 of a pi. So 7/8 of a pi is in what quadrant?
Quadrant 2.
Yeah, quadrant 2. Because it's really close to a full pi. You're in quadrant 2. So you're so close to a full pi that you're in quadrant 2. In quadrant 2, is the sign positive or negative? Oh man, guys, it's positive. Quadrant 2. Because it's sine. All right, last one. And it looks like we're finishing a little earlier than expected, which is fine, because that means we can answer some questions. Sine of 7 pi over 12. Okay, this is probably the hardest question on UH, because this one requires you to think a little bit. And it doesn't require a lot of mental power. It just requires you to pick a coordinate that is perfect. So here's how you tackle it, guys. So it says to use the sum or different angles formula. So what does that mean? That means either use sine A plus B or use sine A minus B, which is what we're going to take a quiz on in a little bit. It doesn't matter which one. You will get the same answer as long as you choose numbers that are correct. So what do I mean by choosing numbers that are on the perfect coordinate? Well, give me 2 numbers that add up to 7 pi over 12 that we know are in the unit circle. Chavez, you're making no sense to me. Here's what I'm trying to say. And I'm giving you these numbers first so you can see what I'm talking about. Do you see, and don't write anything down, guys. I'll give you guys time to write. Just listen right now. Just take this all in as much as you can. Do you see that 3 pi plus 4 pi is 7 pi? So do you agree that 3 pi over 12 plus 4 pi over 12 is equivalent to 7 pi over 12? Okay, perfect. And don't write it down, guys. I see some of you guys starting to move. Don't write it down. I'll give you guys time. Trust me. So I want you guys to notice that 3 goes into 12 4 times and 4 goes into 12 3 times. And this can be rewritten as pi over 4 plus pi over 3. And both of those added together still equal 7 pi over 12. And I want you to notice that these are coordinates that are found in the unit circle. So now I can rewrite sine, and don't worry, I'm going to give you time. Don't write it down, guys. Don't write anything down. Just listen. I can rewrite it as sine pi over 4 plus pi over 3 because the summation of those is still 7 pi over 12. Now, if you don't know what the formula for sine is, it's sine A, so sine pi over 4 cosine pi over 3, and then plus cosine pi over 4 sine pi over 3. Okay, now I'll give you guys time. Go ahead and take a minute to write this down. Does that work better sometimes for you guys, where I tell you guys to just listen and then don't? Okay, so now guys, you just pop open the unit circle or whatever device you would like to use, and you just type in sine of pi over 4 is square root of 2 over 2. Cosine of pi over 3, that is a half, plus cosine of pi over 4 square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. So let's see, square root of 2 over 4 plus square root of 6 over 4. So they're both over 4, so you can just combine them. And I think that's what they did. There it is. Hey, can you guys there at home hear the fan on the laptop? No? Okay.
No, but also the fan on my laptop is really loud.
Yeah, the fan on my laptop is humming along. Do we have any questions on this, guys? Did you guys like today's notes? Did everything make sense?